Now let's move to video 2. So in this example, I'm going to show you the comparisons of the performance from three and controller, the P and PI and PID. And actually, I already shown you this example in the lecture. Now I want to show you and how to use MATLAB to generate the simulation result. So here is the so this is the diagram for the process, and then we have the parameter. I will have the transfer function here, Km, and GV, GP, and GD. And then in this example, I only show you the parameters for the PID controller determined by ZM method. So you don't need to determine the PID controller. You already know the PID controller. So in this example, and the set point change here is we are a unit step set point change. Unit step set change, so equal to 1, and then we have another disturbance and signal which is changed to as a unit step, but with a time delay of, so this is still 1, right, but time delay is 200 minutes. Okay, so we're going to compare the performance of these three controllers. Okay, we don't have to create the simulink model from scratch, right? And we could use the simulink model we just developed from example 1 to make a simulink model for the example 2. So now I want to show you. But one thing you need to be careful is when we set the initial value for the set point change, the initial value should be 0, final value is 1, and the step time is 0. And for the disturbance, the initial value is 0, final value is 1, but the delay time is and the step time is 200. And also when you input the PID controller, you need to input the expanded format of the PID controller, right? As I show you here. You know tau I, tau D, and Kc, but when you make the PID controller in Simulink, you need to input P, I, and D, right? As Kp, Ki, and Kd. So here. So based on the PID controller we have, we could calculate. We could input Kc over tau I as Ki value. We could input Kc times tau D as the Kd value. Right. So for the PI controller, and the tau I, Ki is this value for PID controller. Right. The Ki value is this one, and then Kd value is this one. So Kc is it's equal to Kc. We don't need to change Kc. Right. Okay. So it's very straightforward. So for the P controller we have Kc here. For the I controller we have Kc, and then here Ki equal to 3.63 over 9.59. Right, and then for the PID controller we get Ki equal to 4.48 Kc over 5.76, and then Kd equal to 4.48 times 1.44. Okay, these are the parameters I'm going to input in the Simulink. So now I want to show you how to get the diagram. So as I mentioned, we could use the diagram generated from example 1 and for example and 2. So we save as video 2, but you need to change the parameters for the transfer function. So here we're going to change a little bit, right? That's why I added disturbance in the first example. So you're going to add disturbance. So the disturbance here is 2, and the numerator, right? The denominator is 15. Right, so we get it, this disturbance. And disturbance here, step time is 200, right? Remember, initial values was 0 and final value is 1. Okay. So the disturbance done. And then the GP value here, and here should be 10. Numerator is 2. Denominator is 10, right? And then but you need to add a delay here. The delay time is 1, so we add delay here. The delay should in the continuous one, and here's the should have a transport delay here. Just draw this one into the diagram, and then you put delay time is, let me see, delay time is 1, so you just put 1 here. That's it. Okay, this is 1, good. And then so we already input the GP into the model, and then G and GV is, and here the numerator is 1, denominator here is 5 s plus 1, right? GV is done. So this one, and we could, this is KM, right? So this we don't have KM here, so we just remove this one. Okay, just link them together. Don't have a KM before the comparator, but we still had a KM here, and but the numerator, we just put the numerator and denominator equal to 1. Okay, this is because KM is equal to 1. Okay, so we have the KM. Just we'll try change this one to KM. Okay, KM. So we have KM, and then the comparator, right? The controller, the P controller here, we use the P controller as what is the P controller. We change the value. Yes, you can see from the lecture is 4.03. So this P controller is 4.03. So the P controller, comparator, and GV, GP, and with the delay, and then comparator, another the summation and disturbance, right? Almost there, but we need to specify the input, right? Here is the 0, step time 0, initial value 0, and then final value is 1. So this step time value change. Okay, so we save it. So these 2 we just delete them. Okay, and then we just copy this one, right? And then we just change the PID controller. So copy 1 and copy 2. Let me see. Make one copy, and then we make another copy. Good. So we have 3 copies. Okay. And then so the P, now this is one PI controller, right? PI controller is need to pick P and I. So the PI controller, let me go back to the go back here. So for PI controller, KC equal to 3.63, and then KI equal to here 3.63 over 9.59. That's it. Okay, so you change this one. This one you get it as this one PI controller. PI. Okay, so that's it. So for PID, similarly, we could change this one to here. We could change it to PID, and then let's go back to the lecture and note, and then you get KC equal to 4.84, and then KI equal to 4.84 over 5.76. The keyboard of my computer is not that good. And KD is 4.84 times 1.44. That's it. So let's go back to the diagram. So this one is PID controller. Okay, since we are done, well, the last one is you need to change the name of the. This one should be Y1. This would be Y2 for PI controller, and then Y3 should be PID controller. Okay, let's save it, and then run it. Let me see. The simulation time should be about 400. Okay, 400 minutes. This system is very slow. 400 minutes. Okay, so this is what you should get. Zoom out a little bit, and you will see the whole model. Zoom in a little bit. See? So this P controller, PI controller, PID controller. Alright, now everything's ready. Save it and run it. Hopefully there's no error. Then now what you need to do is you need to plug the output profile. So you could copy the main function from video 1, right, to make a new one, and then you save it. Control S. Then it's main video 2. Okay. Then you need to change the color. Let me see. The color is, what's the color in my lecture here? The color should be RBK. So this should be RBK instead of green. Okay, and then you need to change the region here. The first one is P controller. P controller. Right, and then the second one is PI controller. PI controller. And the last one is PID controller. Control S, save it. Right after, and then you run the simulation because you already run the simulation. Let me see, I think run it again. Make sure that you run the simulation. And then you have the data. After that, and then you just type main video 2. See? This is the result, and we get yeah, the color is a little bit different from the lecture note, but the result is exactly the same. And you need to add the S label, Y label. Okay, add S label, Y label. I forgot to add S label, Y label here. So S label, and the time, minute, and then Y label. You could follow the Y, right? And the font size would be 12. Font size 12. Yeah, I forgot to add the SY label. In the example 1, you should add it, right, to make the figure look better, more professional, right? And then this one is the one we have. Good. So congratulations, we are done with all the videos for the MATLAB training. Hopefully now you are confident to do the job in Simulink.